We're going to look at quadrants and angles in standard position to start with. Let's recall from algebra class that the rectangular coordinate system is broken up into 4 quadrants. In that class, we had X and Y axes, and the quadrants started at the top right, and you go counterclockwise to label them 1, 2, 3, and finally 4. Whenever you have an angle that's in standard position, its initial side is going to be on the positive x-axis. For example, let's look at 60 degrees. The initial side is on the positive x-axis, and then you can approximate a 60-degree angle. Positive angles open counterclockwise, negative angles, and that's a quad 1 angle, by the way. Negative angles open clockwise. So let's take this angle and let's do like a negative 210. Every quadrant contains 90 degrees, so we've got 90, 180, and just kind of eyeball about 30 more and mark off your terminal side. The ray where your angle ends is called a terminal side. Now, because it's a negative angle, it has a clockwise orientation. This one is still considered a quad 2, even though you open clockwise. Once you have an angle constructed and you've got it in standard form, there are other angles that start and stop at the same location, and those are called coterminal angles. For example, let's look at 120. Okay, that angle's positive. So we're going to start it on the positive x-axis, and we're going to open up approximately 120 degrees counterclockwise. Okay, so this is a quad 2 angle. But there are other angles that start and stop at that same location. How many degrees are in a full rotation? 360? That's right. If you start and go all the way around and keep going until you get to that terminal side, then this angle, which is different from 120, also has the same initial and terminal side. What's 120 plus 360? Because all we did was make a full circle. That's right, 480 degrees. 120 and 480 are considered coterminal. They share the same terminal side. What if we were to go clockwise, starting at the positive x-axis, opening clockwise until we get to that same location? How can we figure that out? Maybe if we subtract 360, In the first coterminal angle, we added a full rotation. In the other one, because it opens clockwise, we're subtracting a full rotation. So that is negative 240. A little more vocabulary for angles is complement and supplement. Two angles are complementary if their sum is 90 degrees. If two angles have a sum of 180, then they're considered supplementary angles. Let's look at 80 degrees. That's a quadrant 1 angle. If we draw it in standard position, we start on the x-axis, and then we open approximately 80 degrees. And that's a standard angle of 80 degrees, standard position. Let's do the complementary angle first. Some of these won't have complementary angles. For example, if we had started out with 110 instead of 80, that already surpasses 90, so it can't have a complementary angle. Okay, so remember, for complementary, we are going to look for a second angle that makes 80 become 90. How many more degrees do we need in order to have 80 degrees become 90 degrees? Just 10 degrees. It's very small. But 10 and 80 are complementary angles because their sum is 90. Supplementary angles, we want to go the full 180. Now, if we have 80 degrees spoken for, how many more degrees do we need to go to make it a total of 180? That's right, 100 degrees. So you'll use 180 minus the original angle. To find the supplement to 80. 80 and 10 make 90, so 10's the complement. 80 and 100 make 180, so that's the supplement, 100. Angles are very easy to visualize in degrees as long as it's a manageable number. There are times in many applications actually where we're going to need to have degrees converted to radians. So I'm going to put a little flow chart up here. If we need to convert to radians, most applications in trig involve radian measure. Okay, I'm going to go ahead and put the flow chart up here, and then we might discuss why this flow chart is the way it is. To go from degrees to radians, you're going to multiply by pi over 180. To go from radians back to degrees, multiply by the reciprocal, 180 over pi. The reason this is your conversion is, let's think of a unit circle where it has a radius of 1. Do you remember the circumference of a circle? What the formula is?
2 pi r squared.
It is 2 pi r. Well, if r is equal to 1, that's just 2 pi. Now, if you were thinking pi r squared, that's area. Circumference is 2 pi r. Okay, so for a unit circle, it has a circumference of 2 pi. How many degrees are in a full rotation or a circle? If you were to turn all the way around, how many degrees? 360 degrees. And that's where we're getting the 180 conversion. 180 degrees, if you were to divide both sides of that equation by 2, pi radians is equal to 180 degrees. On the next slide, we're going to practice converting. We've got a little bit of room on this one. Let's see. Let's go with 60 degrees. At the top of your page, to convert degrees to radians, you multiply by pi over 180. What I would recommend if you're going to use a calculator to do this is to type in 60 over 180, or 60 divided by 180. Have your calculator simplify that for you, convert it to a fraction. What you'll find is 60 over 180 reduces to 1/3. If you leave the pi out of your simplification, which is what I recommend, then you can put it in at the end. For example, just do 60 over 180, that's 1/3. Put your pi back in, and it's 1/3 pi. You don't have to write the 1 because pi is good enough. Let's look at a few more examples of converting. Let's see, maybe we want to do 150 degrees. Let's do negative so we get a practice with that one. Now, since we're still going degrees to radians, we're going to still multiply by pi over 180. Negative 150 over 180 simplified is how much? Negative 5/6, that's right. Both numbers are divisible by 30, so that'll help you reduce. Let's go the other way. Let's take 7 pi over 3 and convert that back to degrees. On the previous slide, to go from radians to degrees, you multiply by 180 over pi. It's just the reciprocal. Let's look at this multiplication. The pi's cancel right off the bat. A pi on top, a pi on bottom. 3 goes into 180 60 times. 7, that's 420 degrees, isn't it? Very good. What if I take a negative 2 pi over, let's do 6. Nah, let's keep it with a 3. Okay, so this one is in radian form. if we're going to convert that to degrees, we multiply by 180 over pi. And just like the previous example, the pi's cancel. 3 goes into 180 60 times. The negative 2 sitting over there next to it. Negative 2 times 60. That's right, negative 120. Okay, so let's do one more, and this will just give you an idea of radian. Let's do 1 radian, and we're going to convert that to degrees. Okay. Once we convert this to degrees, I'm going to give you a visual of what 1 radian actually means as an angle. But let's take 180, divide it by pi. If your calculator has a pi button, use it. If not, 3.14 is close enough for this example. 1 radian is equivalent to 57.3 degrees. Now let's think about visually what a radian means. I'm going to draw another circle. Let's pretend that this is a pie or a cake. In order to get 1 radian angle measurement, we're going to make 1 cut into the pie or cake. And then this next part is very tricky. We want to make an equal cut because a circle has a fixed radius all the way around. The idea is the cuts that you make and the length of your crust are equal. The cuts that you make are radius. They're the radii of a circle. And the crust is called arc length. That angle formed from your cake where you cut it, if the cut and the crust have identical lengths, then that internal angle, central angle, is what 1 radian looks like. So now every time you eat dessert, you're going to think about that.